Exercise B6, Curve of Best Fit. Question 1. Which line would you use as the curve of best fit? Justify your answer. So here is a scatter plot about air pressure and altitude. Altitude means how high above ground you are from. And here we have curve A, curve B, and curve C. You have all these data points here. And it looks like curve C is the one that can actually model most or touch the most number of data points. So we can say that C is the best curve of best fit. I can go anywhere on this curve to make a prediction about air pressure and altitude. Question 2. The scatter plot relates the age of a child with the number of hours of sleep needed per day. So here is the graph. Age is the horizontal axis, and sleep needed in hours is shown on the vertical axis. And here is the title. We can say that as the child's age increases, we're reading from left to right, the amount of sleep needed decreases, goes down. Draw a curve of best fit. There it is. C. At age 2, a child should get about 13 hours of sleep. So let's check that. Here is age 2. So we make a line to go to meet the curve. And then we go across. And we notice that the child needs about 13 hours of sleep per day. D. A child who needs approximately 11 hours of sleep per day. So let's find 11 hours of sleep. Draw the line to meet the curve of best fit. How old is this child? The child is about 5 years old. E. At what age do children need less than 10 hours of sleep per day? So they need less than 10 hours of sleep. So let's find 10. And then let's project this across. This is about 9 years old. So it shows that any child who is 9 years old and younger, so this way, they need more than 10 hours of sleep per day. Any child who's older than 9 years old, so 10, 11, 12, they can use less sleep. F. A 3-year-old child needs approximately how much sleep per day? So 3-year-old is halfway between 2 and 4, and he or she will need 12 hours of sleep. Number 3. A football is kicked into the air. The table shows the height of the football every half second. What trend do you see in the data? Explain the trend. So let's plot the data first. So at 0, we're at 0. So half at 0.5 seconds. It's approximately 8.5. We know this at 1, 2, 3, 4, 5. The scale goes up by 1 for height, 1 meter for height. And it goes up by 0.25, a quarter of a second when we go across. Okay, so 0.5 and 8.75 is here. At 1 second, the height of the football is 15 meters. At 1.5 seconds, 18.75. 2 seconds is 20. 2.5 seconds is 18.75. So the ball's coming back. So we notice that, okay, I didn't write it out here, but we notice that from 0 to 2 seconds, the ball's height is increasing. It reaches a maximum or the top height of 20 meters at 2 seconds, and it begins to come down or fall down. Graph the data. Draw a curve of best fit. So here it is. C. What is the football's height at 1.5 seconds? 1.5, it is at 18.75 meters. When is the football at its greatest height? It is at 2 seconds. When is the football 15 meters high? So we have to find height of 15 meters on the vertical axis. And when we go across, it should be at 1 second. And F. What does it mean when the height is 0 meters. Well, it can either be here, or when the ball goes up, we can predict that it's going to come down again. So when the height is 0 meters, the football is on the ground.